Imagine this. A security analyst gets an alert about a suspicious login from an unusual geographic location. The AI security operations copilot springs into action. First, enriches the alert by cross-referencing the IP address with Osiris, pulling in real-time OSINT data like nearby CCTV feeds, flight tracking, and even maritime traffic to build context. If the login coincides with a detected flight route or a port scan from a vessel in a nearby harbor, the system flags it as higher risk. The alert is then prioritized using decision-making agents built with agents towards production. These agents weigh factors like the user's historical behavior, the sensitivity of the accessed data, and threat intelligence from Osiris. If the login is from a sanctioned country detected via Osiris crypto and sanctions modules, the agent escalates it to the top of the queue. Investigation kicks in through Onyx, the self-hosted LLM platform. Onyx uses its RAG, retrieval augmented generation, capabilities to pull related logs from Grafana, analyze code snippets if the login triggered a deployment, and even generate a summary of recent vulnerabilities in the affected system. It might execute a script via Onyx's code execution feature to check for anomalous processes running under the compromised account. Finally, the findings are routed to the right team with an auditable trail. Grafana dashboards visualize the incident timeline, while Gatus ensures the copilot's own health checks and alerting pipelines are functioning. Every step from Osiris data ingestion to Onyx's analysis is logged, creating a transparent audit trail. Under the hood, Osiris acts as the sensor, gathering global intelligence. Agents towards production provides the workflow logic, turning raw data into actionable decisions. Onyx serves as the brain, synthesizing information and generating insights. Grafana handles observability, letting teams visualize incident data, and gatus monitors the system's uptime, ensuring reliability. Together, they form a feedback loop where security teams get clear, prioritized alerts with context, no more sifting through noise. This isn't a Frankenstein of tools. It's a cohesive product where each repository plays a defined role. Osiris observes, agents decide, Onyx investigates, Grafana shows, and Gatus ensures stability. The result? Security teams spend less time chasing shadows and more time stopping real threats. A security analyst starts by submitting a query through the AI copilot's interface, which triggers a data flow spanning all 5 repositories. Let's say the request is to investigate a suspicious IP address flagged by a network sensor. Osiris springs into action first, leveraging its OSINT capabilities to pull live data from NVD for known vulnerabilities linked to that IP, cross-referencing with its global CCTV and flight tracking networks to check for physical proximity anomalies. This raw data is structured into a JSON payload with timestamps, geolocation tags, and threat scores, which gets passed via an API contract to the agent's framework. Agents towards production takes over here, using its multi-agent coordination patterns to split the task. One agent runs a Dockerized Nmap scan through a secure guardrail to avoid aggressive network probing. Another queries a vector database for similar historical threats, and a third enriches the findings with context from Onyx's LLM. The agent's framework ensures each step is stateful, storing session data in a PostgreSQL table with status fields like scanning, enriching, and triage ready. Once all agents report completion, the framework triggers a webhook to Onyx. Onyx acts as the synthesis engine. It ingests the structured findings, uses its agentic RAG module to pull internal documentation or past incident reports related to that IP, and generates a natural language summary of risks. If the IP is linked to a known campaign, Onyx might auto-generate a Yara rule or a Sigma detection signature. These outputs are stored as artifacts in Onyx's file system, with metadata linking back to the original request. Crucially, every action Osiris's data collection, the agent's workflows, Onyx's analysis is logged into a centralized audit store with immutable timestamps. Grafana then visualizes this journey. A dashboard pulls from the audit store and the PostgreSQL session table, showing real-time status of all active investigations. Analysts can filter by threat score, see which agents are active, or drill into Onyx's generated artifacts. Alerts from gatus appear here too if Osiris's CCTV API starts failing or the agent's Docker containers hit resource limits. Grafana triggers a panel alert that escalates through the same routing logic as security findings. Finally, gatus monitors the infrastructure itself. It runs synthetic transactions against Osiris's API endpoints, checks container health for agents towards production, and validates Onyx's LLM connections. If any component fails, gatus routes an incident to the same prioritization engine that handles security findings, ensuring the system heals itself without human intervention. This closed-loop data flow from raw OSINT to visualized action turns fragmented tools into a cohesive security operations platform. Start with Osiris as your data foundation. Clone the repo, run Docker Compose up to pull its stack, and point it at your threat feeds. Test the ingestion by hitting the scrape endpoint manually for each data source flights, CCTV, CVS, then verify the dashboard shows live tiles without errors. Once that's stable, build a lightweight agent using the Agents Towards Production framework. Scaffold a Python agent with a run loop that queries Osiris's API every 30 seconds, filters high-risk entities like military flights near borders or CVEs with CVS 9+, then logs matches to SQLite DB. Test this locally by mocking the Osiris API responses with JSON fixtures to ensure the agent doesn't break on missing data. For the LLM layer, deploy Onyx via Helm chart. Configure its Onyx. Multimount your agent's DB as a persistent volume, then create a custom agent that uses Onyx's RAG plugin to enrich findings with context from internal knowledge bases. For example, when a CVE is detected, the agent should automatically pull related exploit code from GitHub and cross-reference it with your network's vulnerable assets. Test this flow by injecting sample CVEDs into the DB and watching Onyx generate enriched alerts in its UI. Integrate Grafana by setting up a data source pointing to the same DB. Build a dashboard with panels for real-time threat counts, agent uptime, and priority distributions. Add alert thresholds that trigger gatus health checks, like a spike in high-priority findings should ping a Slack channel. For local dev, use Docker to run all services on port 3000 Osiris, 8080 Onyx, and 3001 Grafana, with shared PostgreSQL and Redis instances for state and messaging. Background jobs need a queue system. Use Redis as a message broker. Osiris publishes raw data to a threats channel. Your agents consume and process them, then publish enriched findings to alerts channel. Onyx listens to this channel for RAG tasks, and gatus periodically checks the queue depth to ensure no backlog builds up. In production, deploy to Kubernetes with Helm charts for each component. Use vertical pod autoscaling for Onyx since LLM workloads are CPU-GPU intensive. For the audible trail, ensure every finding includes a timestamp, source IP, and agent version in its DB entry, then use Grafana's logging panel to visualize the chain of custody. Monitor everything with gatus. Create a config that checks Osiris's API latency, Onyx's LLM uptime, and agent queue processing times. Set up Slack alerts for any check failing 3 times in 5 minutes. Finally, run integration tests daily. Inject a test flight path into Osiris. Verify the agent flags it, Onyx enriches it, Grafana displays it, and gatus confirms all systems are green. This ensures the whole chain works from raw data to actionable alert. The AI Security Operations Copilot integrates these tools into a unified workflow. Osiris feeds real-time OSINT data like flight tracking, CCTV feeds, and cyber threat intel into Onyx, which uses agentic RAG to cross-reference indicators against internal logs or threat databases. Agents Towards Production tutorials guide the setup of stateful workflows, ensuring findings are enriched with context. For example, matching an IP from Osiris to a known vulnerability in NVD, and prioritized based on risk scores. Grafana visualizes this data through dynamic dashboards, letting teams drill down into specific events or trends over time. Gatus monitors the copilot's own health, checking API endpoints and database connections via HTTP/TCP checks, with alerts routed to Slack or PagerDuty if latency spikes or a service goes dark. Deploy Onyx via Docker using Docker Compose upd, setting environment variables like Onyx LLMs to specify self-hosted LLMs, for example, Olama, and Onyx MCPP connectors to integrate with security tools. For Osiris, clone the repo and run npm run build followed by npm start, configuring data sources in config, son to enable CVE scanning or CCTV ingestion. Agents towards production demos can be tested by installing the npm package and following labs like security guardrails, which show how to sandbox AI actions, for example, limiting which APIs an agent can query. Grafana requires adding data sources like Prometheus or Elasticsearch via the UI, then importing dashboards to track metrics like mean time to detect, MTTD. Gatus is configured via YAML, defining checks like TTP, probes with conditions for status code and SSL validity paired with Slack, alerts. Limitations are clear. Osiris's real-time data depends on third-party API uptime, Onyx's code execution sandbox has limited library support, and Gatus's checks are synthetic, meaning they can't detect issues without active traffic. Self-hosting requires GPU resources for Osiris's WebGL rendering and Onyx's LLM inference. Licensing is Apache 2.0 for Gatus and Grafana MIT for Osiris, with Onyx using a proprietary license despite being open core. Start by cloning agents towards production and running mpx digit nerddiamant agents towards production tutorial security guardrails security tutorial to explore how to restrict AI actions. Once set up, how would you adjust the priority scoring in Onyx to weigh CVE severity scores higher than geolocation proximity from Osiris data?